given that a continuous beam ABCD, let us mark the points fixed at A, internal hinge at B, and hinged at C, and D is a free end, has a UDL all over the span of intensity W per meter run. This is 2A and this is 2A, and this distance is 4A, and the free overhang is A. Let us find the reactions first. This is RA and this is RC, and a moment here MA. Since it is an internal hinge, it is a determinate beam, we can solve for the reactions. First, RA plus RC will be equal to unit load or unit UDL all over the span, and here it is given that there is a 2.5 WA load. So this plus 2.5 WA, from which let us put it aside, and equating moment at B to 0 for the right hand span, we get RC into 2A equal to W into 3A into 3A by 2 plus 2.5 WA into 3A. On solving, we get RC to be 6 WA, then RA will be, substituting it in the equation 1, we'll get RA to be 1.5 WA. This is 1.5 WA, this is 6 WA. Again, equating moment at B on the left hand span, we can get MA to be equal to W into 2A into 2A by 2, that is W 2WA square is MA. This is 2WA square. Now let us redraw that again to draw the bending moment diagram. Total UDL all over the span, W per meter run, a internal hinge shear, a support at C, a point load at D, A, B, C and D. This is fixed. Reactions are MA is 2WA square, this is 1.5 WA, and this is 6 WA. For the shear force diagram, we know that right upward is negative, since right downward it should be positive 2.5 WA, and since it is a UDL it should vary linearly, and here it will be at C, shear force at C, it will be 2.5 WA positive plus W into, this is A and this is 2A and 2A, right? So W into A, that will be 3.5 WA, so a magnitude of 3.5 WA, and since this is to the right hand side, just to the right, shear force at C just to the left will be plus 3.5 WA, downwards totally minus 6 WA, which will be minus 2.5 WA. So let us draw it here, minus 2.5 WA downwards. Now here shear force left up is positive, so this will be 1.5 WA. Since it is a UDL, it should vary linearly, so joining that we'll get the shear force diagram in which this is positive, positive and negative. From similar triangles we can find this distance where it touches, or shear force changed its sign, and it will be 2.5A this side and this is 1.5A. For the bending moment diagram, since it is a hogging moment, it will be downward 2WA square. and since it is an internal hinge here and a UDL, parabolic variation, and at internal hinge moment bending moment will be 0, and again a parabolic variation, since this is the hogging moment it will be downwards negative, and this also negative. Let us find this magnitude. Bending moment at C will be 2.5 WA into A with a negative sign since hogging, minus WA into A by 2, which will be 3WA square with a negative sign. This is 3WA square. So this is the bending moment diagram, and this is the shear force diagram.